So dear students, welcome to another lecture of digital control system. In this lecture, we will discuss about the shifting theorem in Z transform. Now, what is shifting theorem? What is a time shifting actually? So time shifting is basically the shift or change in the occurrence of any particular sample. For example, if we have a unit impulse signal, so unit impulse signal is basically 1 at k is equal to 0 and 0 elsewhere. That means at the 0th point or 0th sample or at k is equal to 0, the value of this particular signal is 1, otherwise it is 0. Now if we shift this particular sequence, this particular signal, so if we shift this, now shifting can be done in two ways. Either we can shift towards right side or we can shift towards the left side, right? So there can be two types of shifting. Either we can shift this particular, let us say, this signal towards the right side, or we can shift it towards the left side. So if we shift delta k towards right side, right? Now delta k, if we represent delta k, so delta k is actually like this. So it is 1. This is a unit impulse function, right? This is unit impulse function or unit impulse signal, right? Like that. Generally it is a function. Now delta k is 1 at 0 and it is 0 elsewhere, right? So it does not exist at any other point other than 0. Now if we shift it towards right, that is if we shift it towards this side, so let us shift it here. So we have a new impulse function which is delta k and minus 1, right? So in this case, uh, this particular signal will exist here, right? It will be available at 1 and elsewhere it is then 0. So if we shift this by left, right? If we shift the given sequence, shift delta k towards left, so then graphically we can represent delta k. So towards left means we will shift it towards this side, so it will be delta k minus minus 1, right? So minus minus, that is we are taking it towards the negative samples. Now when we are taking it towards the negative sample, for example this is 0 and this is for example minus 1. So in this case this delta k will exist here, and since it is a unit function, so its value will be 1. So elsewhere it is 0. Now what we have done, originally this delta k exists at 0. Its occurrence is at k is equal to 0. However, when we shift this particular function, so its occurrence or its existence changes in time, right? So this is what shifting is, right? And shifting is a very important concept which is used in discrete time systems, and it is used in various for various types of applications, right? Now in this particular lecture we will discuss about the shifting property of Z transform, and which is also known as shifting theorem, right? We also call it as shifting theorem. And there are two types of shiftings actually. Now there are two types of shifting which are studied in Z transform. One is the forward shift, which is also known as advanced shift or left sided shift, right? So that means we shift the sequence towards the left side, that is this one. So means we consider the negative samples, right, or negative values. Similarly, the second type of shift is the backward shift, which is also known as delay or right-sided shift. That means this is shifted towards this side, right? If we take the samples on the x-axis, so we shift the given function or given signal towards the left side. That is, we take the positive values of all the samples. So here we are taking the past and present. Here we take the future values also, right? We consider the future values, right? So now let us start with the advance or forward shift. Now consider a sequence yk. So this yk is a sequence, and we will shift. Let yk is shifted uh, towards left side, because forward shift is also known as left sided shifting. That means we are shifting the given sequence towards the left side, right? Towards left side one sample by one sample. Now that is, we have y k minus and minus 1. So this could be written as y k plus 1, right? So this is the forward shifted sequence, right? Now the z transform of this particular sequence will be y k plus 1, and this would be written as, so we have k is equal to 0 to infinity y k plus 1 and z raised to the power minus k. So this is the standard formula of z transform. For example, this is equation number 1. Now if we multiply this equation by z and divide by z, then what will be the uh, output? Z transform of y k plus 1 is summation k is equal to 0 to infinity y k plus 1 and z raised to the power minus k into z divided by z. Now we'll take it here, right, and we'll take this one outside. Okay, so this particular z will be taken out of the summation. So z summation k is equal to 0 to infinity y k plus 1 z minus k into z minus 1, because we have taken this z on the numerator side, so it will become z raised to the power minus 1. So we can further simplify this equation as like this. So z and summation k is equal to 0 to infinity. So we have y k plus 1 and z minus k plus 1, right? So let us say this is equation number 2. Now put k plus 1 is equal to m in equation 2. Now if we do so, we will have z transform of y k plus 1 as z summation k. Now here the limit will change on the summation. Now if k is equal to 0, m is equal to 1. If k is equal to infinite, m is also infinite, right? So we'll take m here. M is from 1 to infinity. So it will be y m z raised to the power minus m. Now this is equation number 3, for example. Now this equation seems to be the z transform of some ym, but it is not z transform because m should start from 0. The standard representation is m is equal to 0 to infinity ym z raised to the power minus m. So this could be some yz, right? But since we have the starting limit as m is equal to 1, so now that means we need to add one sample to this. Okay, so let us do so. So z transform of y k plus 1 is equal to z summation. So now what we'll do, we will m is equal to 1 to infinity, and we'll take ym z raised to the power minus m. Now the zeroth sample is not here, so we add the sample at m is equal to 0 in 3, equation number 3, right? So what we'll do, we'll add y0 z0 and we'll subtract that one, because that will not make any difference in this. If we do so, these two will cancel and we have the same equation, so it doesn't make any difference, right? Now these two terms, right, these two terms is equal to m is equal to 0 to infinity ym z raised to the power minus m, right? So this is now the z transform of some ym, right? So this is the z transform of ym, which is yz, right? So now, okay, so now we have the z transform of y k plus 1 is equal to z. Now we have the bracket here, so we have summation m is equal to 0 to infinity ym z raised to the power minus m minus, and then we have one more term here which is y0, because z raised to the power 0 is 1, right? Now we'll open this one, so we have z. Now this is nothing but yz and minus z y0, right? Now this is the z transform of a sequence yk which is shifted towards the left side by one sample, right? So this is, for example, your equation number um, 4, right? So now if yk is shifted towards left side by two samples, then z transform of yk minus minus 2. So now we have shifted it uh, uh, for two samples, right, towards left. So it would be z transform of y k plus 2, right? So this would be summation k is equal to 0 to infinity y k plus 2 z minus raised to the power k. Uh, Okay, z raised to the power minus k. So this is, let us, equation 5. Now we'll do the same thing. We'll multiply this equation with z square and we'll divide with z square, right? So by doing so, what we have z y. k plus 2, and we have this summation k is equal to 0 to infinity yk plus 2 z minus k into z square into z raised to the power minus 2, right? So this will give me z square and summation k is equal to 0 to infinity yk plus 2 z raised to the power minus k plus 2, right? Now we'll put, this is for example equation number 6. We'll put k plus 2 is equal to m in equation 6. Now in this, we need to change the limits also. For k is equal to 0, m is equal to 2, k is equal to infinite, m is also infinite, right? Now, when we do so, we have yk plus 2, and then we have the z square and summation m is equal to 2 to infinity. So ym and z raised to the power minus m. Now here this part is starting from m is equal to 2. So we need to add samples at m is equal to 0 and m is equal to 1 in this equation. So by doing so, what we have? We have z transform of y k plus 2. Now what we'll do? We will add summation m is equal to 0, 2 to infinity ym z raised to the power minus m, plus we'll add a sample at 2 and z raised to the power minus 2, right? Plus we'll add a sample at not 2, sorry, we'll add a sample at 0 and z raised to the power 0, sorry, and we'll add a sample at 1 and z raised to the power minus 1. Now we'll subtract the same samples because that will not make any difference, right? Minus y1 z raised to the power minus 1, right? Now, so now these three terms, this one, these three terms, this is equal to summation m is equal to 0 to infinity ym z raised to the power minus m. So this is the z transform of some sequence ym, which can be written as y z, right? So now we have z transform of y k plus 2 is equal to z square yz, and then we have minus y0 and minus z inverse y1, right? So we'll open up the brackets. We have z square yz minus z square y0 minus z inverse and z2, so it would be zy1, right? So now if we see the trend here, if we see the equation number 4 and let us say this is equation number 7. So if we compare these two equations, if we see these two equations, we'll find that if yk is shifted towards left by n samples, then we have yk minus n, right? So it would be yk plus n. Then z transform of y k plus n will be, now what will be the z transform here? Z transform will be, so we can see the trend here. So it is shifted by one sample here, this one, equation 4. So we have z raised to the power 1, and then we have z raised to the power 1 here. Then we have a sequence which is shifted by two samples. So we have z raised to the power 2, then z raised to the power 2, then z raised to the power 1. So if a signal, if a sequence is shifted by n samples, so we have z raised to the power n yz minus z raised to the power n y0 minus z raised to the power n minus 1 y1 minus z raised to the power n minus 2 y2 and so on, like this. So this is the solution. This is the output of the uh, Z transform of a sequence which is shifted towards left by n samples, right? So this is some equation number, let us say 8. So this is what we need to understand, right? So this is how we can find out the uh, Z transform of a time shifted sequence. Now here we have taken the sequence which is shifted in advance, or forward shift is there, or you can say which is shifted towards the left side, right? Now let us take the delay or backward shift. So delay or backward shift is also known as um, the right sided shift, right? So this is the right sided shift. Now we'll consider the same sequence yk. Now we'll shift this towards the right side. So shift this by one sample. So we have yk minus 1, right? So now the Z transform of this y k minus 1 is, so we'll write the same equation, k is equal to 0 to infinity, and then we have this y k minus 1 z raised to the power minus k. So this is, let us say, some equation number 1 for this particular concept, for this particular topic. Now if we multiply and divide this equation by z, right? So what we will get, z y k minus 1 is equal to summation k is equal to 0 to infinity y k minus 1 z raised to the power minus k into z raised to the power 1 into z raised to the power minus 1. So we'll take this one outside, right? So we'll have z raised to the power minus 1 summation k is equal to 0 to infinity yk minus 1 z raised to the power minus k minus 1. So this is, let us, equation number 2. Now if we put k minus 1 is equal to m in equation 2. So in this, for k is equal to 0, m is equal to minus 1, k is equal to infinity, m is also equal to infinity. So now the limit will also change the summation. So we have z transform of yk minus 1. So this is summation m is equal to, so z inverse is outside, so m is equal to minus 1 to infinity ym z raised to the power minus m. Now if you see here, we have this summation starting from m is equal to minus 1, right? So that means we have one extra sample with us at m is equal to minus 1, right? So we'll subtract this one. How? So we'll take the z transform. So we have y k minus 1 here. So we have z inverse summation. Now I will take a bracket here. So m is equal to minus 1 to infinity ym z raised to the power minus m. Now if we subtract the sample at m is equal to minus 1, so it is minus 1 z raised to the power minus into minus 1, because we have one extra sample, right? So we'll subtract that sample from the given summation. From this particular summation we will subtract that particular sample. So now, but to neutralize this equation, we will add the same sample here. So plus y minus 1 z raised to the power minus into minus 1, right? So this is how we will do. Now, so we'll further simplify this one. Z transform of y k minus 1 is equal to z inverse and summation. Now, these two terms here, these two terms will, give us, these two terms will give us this one. So we have now m is equal to 0 to infinity ym z raised to the power minus m, and the rest of the term will be as it is, y minus 1 z raised to the power 1, right? Because now we, when we have subtracted the sample at m is equal to minus 1 from the summation, so now we have the summation from m is equal to 0. Now this particular is basically the z transform of some sequence ym, which can be written as yz, right? So we have z transform of y k minus 1 is equal to z inverse. So we have yz plus y minus 1 z, and then we'll open up the bracket. So we have z inverse yz plus, now this z and this z will be cancelled out here. So we have y minus 1. So this is, let us, equation number 3. Now this is the z transform of a sequence which is shifted towards right by one sample. Now if yk is shifted towards right by two samples, then z transform of yk minus 2, k minus 2, because yk has been shifted by two samples, right, is given as, z transform of this particular sequence is given as z transform of y k minus 2 is equal to summation k is equal to 0 to infinity yk minus 2 z raised to the power minus k, right? So this is, for example, equation number 4. Now similarly, we'll multiply and divide this equation by z square and z square, right? So we have z transform of y k minus 2 is equal to summation k is equal to 0 to infinity y k minus 2 z raised to the power minus k into z square into z raised to the power minus 2, right? So we'll take this z raised to the power minus 2 outside, right? So we have z transform of y k minus 2 is equal to z inverse square summation. So k is equal to 0 to infinity y k minus 2 z raised to the power minus k minus 2. Now this is, for example, equation number 5, right? So now if we put k minus 2 is equal to m in equation 5, now we'll change the limits also. So limits will be for k is equal to 0, m is equal to minus 2, k is equal to infinity, m is also equal to infinity, right? So z transform of y k minus 2 is equal to z inverse square, and then we have summation m is equal to minus 2 to infinity ym z raised to the power minus m. Now this particular sample starting from m is equal to minus 2. So what we'll do, we have two extra samples here. So now we have two extra samples, that is at m is equal to minus 2 and m is equal to minus 1 in this equation. Now what we will do, we will subtract these two samples from the given summation. Okay, so z transform of y k minus 2 is equal to z inverse square summation m is equal to minus 2 to infinity ym z raised to the power minus m. So we'll subtract the sample at y minus 2, z minus minus 2, and we'll subtract at y minus 1 also, z minus minus 1. But we will add these two samples also here, so that the equation remains unchanged. So z minus minus 2 plus y minus 1 z raised to the power minus minus 1. So this is how we will do. Now these three terms, okay, these three terms are equal to summation m is equal to 0 to infinity, because you have subtracted these two extra samples here from the summation. So it would be starting now from m is equal to 0. So it is m summation m is equal to 0 to infinity ym z raised to the power minus m. So this is the z transform of some sequence ym, which can also be written as y z, right? So now we will simplify this one here. So we have z transform of y k minus 2 is equal to z inverse square. So these three terms are equal to yz, right? So minus, no, sorry, plus y minus 2 z raised to the power 2 plus y minus 1 z raised to the power 1. Now we'll multiply it here, right? So we have z transform of y k minus 2 is equal to z inverse square yz plus, now this z inverse and this z square will be cancelled out. So we have y minus 2, and now here we have 1z, here we have minus 2. So it would be z inverse 1 y minus 1. So we can write this as z inverse square yz plus z inverse y minus 1 plus, so here we can write z 0 y minus 2, right? Now if we see this trend, this is let us equation number uh, let us equation number 6, for example. Now from the trend of equation, now equation 3, here we have equation 3, this one, right? This equation and equation 6. So let us write these equations. So if you see here, the sample was shifted towards right by the sequence was shifted towards right by one sample. So we have z raised to the power minus 1, then here we have z raised to the power 0, and then minus 1. Now you can see the trend here when the same sequence has been shifted towards right by two samples. Now we have z raised to the minus 2 yz, then minus 1, then z 0, and here minus 1, minus 2, and so on the sequence would be. Now if the same sequence yk is shifted towards write by, let us say, n samples, then z transform of y k minus n, right, can be written as, so by seeing the trend we can write z raised to the power minus n yz, then plus z raised to the power minus n plus 1, because if n is equal to 2, so z raised to the power minus 2, minus 2 plus 1 is minus 1, you can see here, right? So it is y minus 1, right? Then plus here it is z raised to the power 0, so we can write z raised to the power minus n plus 2, so it is y minus 2 plus z raised to the power minus n plus 3, y minus 3, and so on, right? So this is, let us say, equation number 7. So this is what to uh, the z transform of a sequence which is shifted towards right, or which is having a delay shift or backward shift and shifted by n samples. So in this way you can find out the z transform of such sequence. So this equation number 7 can also be written as, so we can write it z transform of y k minus n is equal to z raised to the power minus n yz, and then we have plus z raised to the power minus n minus 1 y minus 1 plus z raised to the power minus n minus 2 y minus 2 plus z raised to the power minus n minus 3 y minus 3, and so on, right? Because what we have done is we have taken this negative sign common from these terms here, right? And we have got this equation. So now this is how you can find out the z transform of the time shifted sequence, and this is very important in z transform, and it will be used in the designing of the controllers also later on in this particular unit. So this is all about today's lecture. Thank you so much.